Okay, this video is an introduction to the process of factoring, which is dividing polynomials. In this video, we're concentrating on second-degree polynomials, which are also known as quadratics. So, a reminder before we begin that factoring is dividing. It is the process of dividing polynomials of different degrees so that we can find their factors. Quadratics, in particular, second-degree polynomials, can be monomials, they can be binomials, or they can be trinomials. Quadratics have a particular way to name their coefficients, and that way to name their coefficients is standard, regardless of whether the quadratic is a monomial, a binomial, or a trinomial. A is always the coefficient that is associated with the squared term. B is always the coefficient that is associated with a linear term. And C is the constant and stands for constant. So, why do we factor polynomials of any degree? It turns out that not all polynomials can be factored. But those that can give us pretty handy information about their graphs. So let's go to Desmos and take a look at some quadratic expressions, both binomials and trinomials, and I would like you to notice something about the factored form and the graph. So I wanted to show you guys, I wanted to finish this sentence before I stopped and we jump to Desmos to take a look. So let's take a look. Here is one quadratic right here. 5x squared minus 10x. So it's a parabola. And I want you to now that you're looking at the parabola, look at the factored form of the parabola. You'll notice it's the same line, but I want you to notice in particular, I want you to look at these two factors, and I also want you to look at where the graph crosses the x-axis. And I want you to pause the video for a moment and tell me what you notice. So here we have 5 times x, and we also have x minus 2. And the 2 points on the graph where the parabola crosses the x-axis is at when x equals 0 and when x equals 2. X equals 0, x equals positive 2. Let's look at another one. So here's another quadratic binomial, 4x squared plus 12x, and here is the factored form of that same quadratic. You can see it's the same line, and once again, look at the two factors. We have 4x, and then we have x plus 3, and I want you to note where the graph crosses the x-axis. It crosses at when x equals 0, and it crosses when x equals -3. And before we move on, here's a trinomial quadratic, a quadratic trinomial. And it factors into x plus 8 times x plus 8. Now, it's a little different than the parabolas that we saw before, because this one doesn't cross the x-axis. It touches the x-axis at one place, where x equals -8. So what I was hoping that you would notice in these three examples is that these factors tell you where the parabola either crosses or touches the x-axis. And it happens to coincide at how you make y equal to 0. What do you have to plug in for x in this binomial to make it equal 0? Well, -8, of course. Just like in this parabola, where does the parabola cross? It crosses at -3, and it crosses at 0. This stuff will start to make more sense as we go forward. My purpose right this minute is just to let you see why we factor quadratics and what they can tell us if they are factored about their graphs. So, to finish this video, let's go back to the document camera. We factor polynomials to see where the graphs cross the x-axis, where y equals 0. We also call these points the zeros of the function, and we will learn more about that as we go on. In the next video, we will concentrate on the actual procedure for factoring a quadratic, whether it be a binomial or a trinomial. The methods hold. Thanks for listening.